Hello everybody, in this video I'm going to show you a few simple combinatorial identities. These identities are identities that every mathematician should know, and they're really helpful in counting and probability questions where there's a lot of combinatorics. So, let's get started. Okay, so the first one we're going to start with is a really simple combinatorial identity that most people already know, but we're going to prove this combinatorial identity. The fact that n choose k equals n choose n minus k. Now, we can prove this really easily with a committee-forming argument, which we'll see what it is later in this video. So, n choose k denotes the number of ways to make a K-person committee. So, we already know that the choose function takes the number of ways to make a K-person committee. And this should be pretty obvious. If you don't know this, then you might not want to watch this video further because you're going to need to know some of this basic stuff. And on the other hand, we have n choose n minus k, which is basically the same thing, except it's the number of ways to choose n minus k person committee. And you may be wondering, how are these two things equal? Well, let's say we're trying to find the number of ways to make a K-person committee. However, how is this equal to this? Well, when we're choosing an n minus k person committee, technically we're also choosing a k person committee, because if we choose that n minus k person committee, there will be k people left behind. So technically we've actually chosen a k person committee to stay behind. So it can be equivalent to the number of ways to make a k person committee. So therefore, these two are equal. The next combinatorial identity that we'll be seeing is slightly more complicated, and it will take a little bit of thinking, and we might use some different methods to try to prove that combinatorial identity. And remember, if you remember how to get these identities, instead of just memorizing these identities, then they'll be much easier to memorize. This one is called Pascal's identity, and it's defined by Pascal's triangle. We're going to prove this with a committee-forming argument like before. So, we know that this means the number of ways to choose k people to form a committee from n people. And for this side, we're going to imagine that there's a person named Bob. And this, as we can see, will count the number of ways of groups that has Bob in it. Number of committees that has Bob in it. So, since Bob is automatically on the committee, then there's only n minus 1 people to choose from. And since Bob is already on the committee, we only have to choose k minus 1 people. This one counts the number of ways to not have Bob on the committee. So, again, there's n minus 1 people to choose from because we can't choose Bob, and we're choosing k people from those n minus 1 people. So when we add these together, Bob and not Bob, number of ways for those, and we'll get the number of ways to choose a committee of n choose k. And now we're going to move on to our next combinatorial identity. This identity is known as Vandermonde's identity, and I don't think I pronounced Vandermonde correctly. So in the comments, if you feel like it, you can correct my pronunciations if you really have OCD problems. So first of all, we have summation notation right here, and that's pretty confusing. So what we're going to do is take away that summation notation and write this part as a actual sum. Okay, so I've finished writing out the summation, and I added the m plus n choose r at the very right side. And so we're going to start proving this with a committee forming argument. So say that there are a group of m plus n people, and we want to choose a committee of r people from them. And say m stands for the number of men we have. So m equals number of men in this random group of people, and n stands for the number of women. And so this first part states that we're choosing all our people from women. So our whole committee is made up of women. So it's basically each of these things are just kind of just cases. So this case right here is if we choose one man to be in our group and the rest all be women. This one is when we choose two men and we have r minus 2 women in our group. So as you can see, this just all adds up for the cases for choosing r people from m plus n people of groups of men and women. So as you can see, it wasn't actually that hard. In next videos, I might add some more combinatorial identities, and I hope you enjoyed this video. Thanks for watching.